Okay, welcome back. This is going to be the second part of the lesson. The first was discussing about Pythagorean theorem. And now what we're going to do is we're going to look at this area of trig ratio. So I want you to take a look at this triangle. Now notice again that this is a right triangle. So the right triangle we're going to use not only for the Pythagorean theorem, but also for using these trig ratios. Now, there's a couple of terms that we do use. With this right triangle. One is sine. Now you can look at your calculator on these three terms. They should be on your graphing or your scientific calculator. But sine, S-I-N, cosine, C-O-S, and then if you look down here, tangent is T-A-N. Now, what we're going to do is with these trig ratios, we're trying to find the ratios of either angle A or angle B. Now, when you see whether sine, cosine, or tangent of a specific letter, in this case the first one is A, I'm looking at the perspective of A right here. Okay? So what I mean by this is sine is always opposite. Opposite of big A is little a. So I'm going to put little a right here. Now a new term is the hypotenuse. The hypotenuse is the longest side, or it's the side opposite of the right triangle, which is little c. So I'm going to put A over little c. Now let's take a look at the sine of B. Sine of B is the opposite of big B, which is little b. And then it's always over the hypotenuse, which is c. The hypotenuse is always going to be c. Now I'm going to scroll down a little bit. Cosine is always the adjacent over the hypotenuse. The adjacent is the side that's not the hypotenuse that is touching the angle. So in this case, B is also touching angle A. So B is the adjacent. The hypotenuse is always C. Now, if I scroll up just a little bit, the adjacent, when I'm looking at angle B, the other side besides C that's touching angle B is little a. So I'm going to put little a over little c. And then finally, the opposite tangent of A is the opposite, which is little a, over little b, which is the adjacent. So opposite of adjacent is A over B. Now for the tangent, the opposite, if you look at the sine, is the B. And then for the adjacent, you would look at the cosine, which is A. Now there's a couple of different ways that you could check yourself. Sine A right here is always the same as cosine of B. So both of them have the ratio A over C. Now the cosine of A and the sine of B are always the same. In this case, they're B over C. And your tangents are the reciprocal, or basically it's the fraction that's flipped. So the tangent of A over B is, if you flip it, gives you the tangent of B, which is B over A. So now we're going to put some numbers along with this. Okay, so if you need to go back in your notes and look, that is perfectly fine. Now, I'm going to do the first column, which are my A's. Now, I'm going to look at this perspective of A. So if you want to pause this, you can go ahead and see if you get these numbers with the ratios correctly. and then you can unpause it and come back to us. Okay, so from the perspective of A, sine is always opposite. Opposite is 3 over the hypotenuse, which is C. In this case, it's 5. So this is all I'm looking for, 3 over 5. Cosine. Cosine is adjacent, which is the other side that's not the C, that's touching the angle A, which in this case it's 4. So it's 4 over the hypotenuse, which is 5. And finally, the tangent is the opposite, which was 3, over the adjacent, which is 4, so it's 3 over 4. Next, look at sine B, cosine B, and tangent of B. So now what I'm doing is I'm looking at the perspective of B. So now the opposite of B is 4. The hypotenuse is always 5. It's always the longest side. Cosine of B now is the side touching B that's not the hypotenuse. So in this case, it's 3. So 3 over 5. And finally, the tangent of B is the opposite 4 over the adjacent, which is 3. So that gives me 4 over 3. So now, one way, like I said, you can check your work, because angle or sine of A right here is the same as cosine of B. In this case, it's 3/5. Cosine of A is the same as sine of B, which is 4/5. And finally, my tangent of A is the reciprocal, or the fraction flipped over, of tangent of B, which is 4/3. So we know we're on the right track. Now, finally, what they like to do is they like to go ahead and give you a missing side. So first we need to do is use our a, since this is a right triangle, use our a squared plus b squared equals c squared. Now what I'm going to do is I'm going to go ahead and label this. So I'm looking at big A, opposite is little a, which is 5. My little c is opposite of big C, which is 13. And B is what we're trying to find right here. So now all I'm doing is I'm putting 5 in for A, so 5 squared. Not doing anything with B squared. C squared is 13 squared. Now if I square these, it's 25 plus B squared equals 169. Then we're just going to do some simple math, bringing the 25 over. B squared equals 144. Now, 144 is a perfect square, so if you take the square root of 144, B equals 12. So this B right here, I'm going to put in 12, so we know what that is now. It's 12. So if I come back up here to sine A, and cosine of A and tan of A, or tangent of A, I'm going to put in my ratios. So I'm looking at the A's perspective now. Opposite for sine is 5 over the 13, which is the C, which is the hypotenuse. Cosine of A is the 12, because 12 is touching A. So it's 12 over the hypotenuse of 13. And finally, tangent is going to be opposite, which is 5 over the adjacent, which is 12. So my ratio is 5/12. Now, I'm going to look at the B's perspective. So I'm looking at the B's perspective up here. Opposite of B is 12 over the hypotenuse, which is still 13. Now the adjacent, which is 5, that is touching angle B. So it's going to be 5 over the hypotenuse, which is still 13. And then tangent is always opposite, which is 12, over the adjacent, which is 5. So 12 over 5, that's my fraction, or my ratio. Now let's do just a little simple check. Take a look at this right here. Cosine of A and sine of A, cosine of B are the same. They're 5 over 13. Cosine of A and sine of B are the same, and that ratio is 12 over 13. And then notice my tangent of A, if you flip the fraction or take the reciprocal, it gives you 12 over 5, which is the tangent of B. So this right here concludes my lesson on trig ratios. So please go back and review this as much as you can. And this leads into my next lesson of 13.2. Thank you very much.